In this functions exercise, we are going to evaluate the domain and the range of this function over here. Now, we are going to first focus on the domain of the function. So we need to take some things into account. We need to mostly check where the function is not going to exist. So if we take a look at the function, the only moments where it's not going to exist is when this part up here is negative. Technically, it does exist in the complex plane, but in the Cartesian coordinates, you cannot represent it. So you might want this part over here to be either 0 or more. So x minus 4 has to be more or equal to 0. So x has to be more or equal to 4. So that's going to be the domain. The domain is going to be from 4, including 4 because the square root of 0 exists, towards plus infinity, that way. So if we now take a look at the range, we want to evaluate how the function exists in the y-axis. So what we want to do is we want to predict what kind of values the expression will return when we plug in values of x. So there are three things that we need to take here into account. Is it going to return negative values? Is it going to return 0? Or is it going to return positive values? So if we take a look, it's not possible that it will give negative values, because if it gives this part over here, if it gives a result, it will always be between 0 and infinity. So negative values are out of the picture, but it does give values where y is 0, when x is 4, y is 0, and for any kind of value of x being greater than 0, we will also have a y value. So the range of the function goes from 0 to infinity. So then we include 0, and we go all the way towards infinity. That will be the domain and the range for this function. So this is another exercise regarding functions, and we have the same function as in the first exercise, and we have a new function. And what we need to find here is the combination functions of these two. There are two combination functions that we can get, is either the first one enclosed in the second one, or the second one enclosed in the first one. So let's first go to g of f of x. So this expression over here, you can also write it as g of f of x, and then what you do is you substitute f of x with what f of x actually is. So, and then you just substitute this part inside what g of x is. So you have 4 times, there we go. And then you will notice that if it's squared on a fraction, it will be squared either like both here and here. So it's the same as saying 4 times this part over here squared, so the square root cancels out, x minus 4, and then it's divided by 2 squared, and then 4 and 4 cancel out. Therefore, x minus 4 is the answer to this exercise. Now we are going to go to the other kind of combination we can make here, which is in reverse. So f of g of x. So it starts this way. Just f of g of x. Now what we're going to do is g of x, we're going to write how the expression actually is. So f of 4x squared. And now this part, we're going to put it inside this x. So it's going to be square root of 4x squared minus 4 divided by 2. And now what we're going to do is we're going to simplify this expression. So square root of 4 times x squared minus 1 divided by 2. The 4 is 2 squared, so you can go outside of the square root as a 2, and it will cancel out with this one. So it will end up being the square root of x squared minus 1. And this is the solution to this other part of the exercise. So this exercise, we are going to calculate the inverse of this same function we have dealt in the 2 previous exercises. So first, I want to offer a visual representation of what it should actually look like. and then we will deal with it analytically. So by looking at the domain and the range we have looked in the previous exercises, the function will more or less look like this. So if this were to be 4 in the x-axis, it will look something like that. So if we draw an x equals I and we make a mirror image based on that, what we would obtain is a graph that looks more or less like that. So now let's jump into the analytical part of it, and let's see what happens. So the first thing we need to do is we need to redefine the variables. So one of them is the independent. Now it turns into a dependent, and vice versa. So this f of x we usually interpret as y is now our new x, which will be equal to our new y inside this structure over here. And the only thing that we need to do is just move things around. So what we will be doing is move the 2 here, so this is 2x equals square root of y minus 4, then we square both sides, so 4x squared equals y minus 4, and then we just move things around, and y equals 4x squared plus 4. And technically speaking, this should be the analytical solution to the exercise, but if you go to GeoGebra and you plug this in, you will realize that it doesn't apply here, because you will see that it actually has an extension, a symmetrical extension on the other side. Now, this does not mean that you did it wrong. This means that you added some kind of technicality when you squared things. So that's when you need to start looking at how the domain and the ranges affect. So here you know that x does not exist when it's smaller than 4. So x has to be greater than 4. So when you invert it, the y still needs to be greater than 4. And you have to carry out this limitation throughout all the steps. So while this is the correct solution, you do need to specify that y must be greater than 4. And this is the most correct solution for the exercise.